I'm pleased to introduce the next speaker at Launchable, Jay Alammar. Thanks very much for joining, Jay. Jay is the Director and Engineering Fellow for NLP at Cohere. And in that role, Jay advises enterprises and the developer community on how to use these large language models best to solve real-world language processing use cases. Thanks to Cohere for being a Launchable sponsor, and thanks for joining, Jay. Welcome.
Thank you so much. Great to be here and joining you. It was a great session. Happy to be sharing some ideas with the audience on these very fascinating topics. So thank you for having me. Let me see if I can share my screen here. And I think we're good. See my screen? All right, perfect. So let me just, I'm going to share a few points about this idea I've been going around and telling people that generative AI is not enough. And this group would know what generative AI is, but I just talk about image generation and text generation as two things that are at this moment maybe are foundational concepts for generative AI. So just the last few years, we're able to have models that generate incredible imagery, designs, but also incredible text. These are some of a couple of image generations. I was really impressed in some of the DALL-E ones that were plugging Kermit the Frog in Star Wars, or plugging Kermit the Frog in The Matrix, in Blade Runner, even catching this cyberpunk sort of aesthetic of the genre, but also the film itself. And this one where DALL-E was putting in Kermit the Frog in Spirited Away, and it looks like an anime. And this is really interesting behavior because these models were not trained specifically to do this. And so we see this also with text models where it's this few shot or one or zero shot even behavior where the model is able to show you an output of something that is quite complex that the model specifically was not able to, but because a large enough model was trained in a large enough data set, it's able to get that output and win art contests. In products, the name generative AI sort of started to be used more and more in the VC and entrepreneurship ecosystem to describe the new category sort of emerging from products and in companies in this space. So where that is text generation or video or image or code. So these are the two types of models. They're definitely not the only ones. And definitely this year, we'll see a lot more productized and open source models that do more types of generation. But for now, we can say that we have text generation models and image generation models. There's video generation in research and some efforts here and there. There's work on music and other modalities as well. And in Cohere, we see text generation because we train and deploy these models and we see how people use them in the real world. And so these are some of the ideas and things that we've learned sort of from this space. So I had these images here where each circle is a model. So this is a text generation model and an image generation model. But then since we're talking about generative AI, let's actually generate proper icons for this using generative AI. So this is our language model, and then this can be how we refer to image generation models. So generative AI is impressive. That because we're all here, I think we can all agree on that. The challenge is, or one of the challenges is that it's not reliably impressive. One of the best examples for this is Stack Overflow banning posts by ChatGPT, and the reason there is that they sound really well informed, but on average they're not sort of solving that specific problem. And that's, this generation of language models is able to do well on, things that are help you, brainstorm. But if you need something with a very high precision, maybe a generative model can be assisted by other types of models. And something like this Stack Overflow ban is a little interesting because it kind of penalizes a model for generating text that is very coherent. And the challenge is, the trustworthy that comes across with that coherence. And it's like reminiscent of if you do computer graphics really well and you get really close to realistic graphics, you get to that uncanny valley that where you're punished for getting that close, but then that's just a hurdle for you to jump to the next level. One really important sense to develop as one navigates the generative AI and the constant developments and the surprising and shocking developments that will come every month or every 2 months is to manage your expectations. And you'll come across demos or tweets showing some behavior, and one of the most important muscles to try to develop is coming across something to think about, is this model behavior that I'm shown in this tweet or demo, is this a cherry-picked example, or is it reliable behavior? Like one of the best examples, this was for me one of the tweets that put GPT-3 really on my map for something that can be transformational, and it really is. But for expectation management, there was this app initially with GPT-3 where you describe the layout of a web page, and the model is able to generate it. And it's incredible that the model can do this, and these demos were also quite incredible. The keyword here is in this tweet. It says it generates the code for it nearly perfectly, and it's 2 years out now, and we don't really have these commercially available websites from text builders, because that nearly is a little bit stretchy. So you might feel that this nearly means this capability can be developed by language models in 2 months. It can also be there, can take more than 2 years, which we are now. So these models are definitely helping a lot of no code or low code applications, but measuring exactly when language models or generative AI models are going to be able to tackle a use case is something that's important to manage expectations there, and not directly assume when we see something that this type of problem or this type of use case is solved. A lot of the times it needs a little bit of time to do that. Another challenge, and this touches a little bit on just the coherence of language models when you see their outputs or chat with them, is you might think of them as brains or as intelligences, and it's very important to fight that urge. But also in the products that you build, that you sort of don't give the users that impression. Now, rather than thinking of them as a mind, you can think of them as the language understanding and language generation components of an intelligent system. And this system can do, various intelligent things. And for a lot of tasks, you don't need a complete human, brain to do something. So these intelligent system that uses generative AI or language models as components in their own space is a more powerful system. And to give an example here, some people are tempted to use a language model for therapy or to diagnose medical conditions. And that is not a very good idea, because these models are trained specifically on language. They might pick up information here or there, but they shouldn't be used for, let's say, high stakes scenarios. But then you can have a language model that tries to understand when people talk about their symptoms. This model can sort of map them to pre-existing or pre-mapped systems. That is a task of language intelligence, and then once it's mapped, a software system or an expert system can help take it to the next level, or get suggestions to an expert, human expert, that would finally sort of render the final result. So as you sort of build and map out how these models work and how to build the systems with them, this is important to sort of keep in mind and resist that urge. One useful design pattern is when you first come across these models, this is the interaction. So you give a model a text input, and you get the output of the model. And if you're happy with it, you're happy. But it's better to think about the generation of the model as only one suggestion, and then you can build use cases where you're actually getting multiple suggestions from the model, and you're choosing one from amongst them. And this goes for both image generation and text generation. So, you see this in the pattern. You see this pattern in, let's say, text writing assistants, kind of like HyperWrite would give you multiple suggestions for how to complete an essay that you're writing. But you also see this with like Midjourney or Dream Studio when you're generating. You see this pattern of the ability to you're not going to be happy with every single generation that the model gives you. You're actually exploring somewhat of a generation space. So UIs that support and empower users to see not just one output from the model, but multiple, is a useful design pattern for generative AI applications that are helping the user. So that's one way of using this method. Another way is that even if you're presenting one generation, or if you're in a use case that has to generate one output to the user, you would benefit. You'd actually get a little bit more of an intelligent output if you do generate 5 or 10 and then choose the best one for any definition of best that you like. So for text generation models, they give you likelihood scores. You can choose using that, but then you can have other mechanisms as well. You can have a classifier that scores these and shows the best one. You can have filters that remove a few of the generations that are not fitting, and then have another step of choosing. So this is another common manifestation that is useful for this idea, to not be happy with just one generation by the model, but multiple. Prompt engineering is still important. So a lot of these models operate on text going in and some generation coming out. And you have to invest a little bit in knowing how to give the model the best prompt to create the output that you want. Now, one of the simplest prompts is to give the model a long article and say, in summary, and the model would expect that based on the probabilities and things that it was trained on, that the next sentences in this article would be a actual summary of. And so that's one way to guide the model to do a useful thing for you. Another powerful tool for text models is to show the model examples of the type of output that you want, but also describe the general setting that you need. So the more information that you give these models about the setting and what you want them to do, the more helpful you are in guiding them to that output. And one common useful prompt technique is the list, where you say this is a list of X or Y, and then you list them. And with prompting, one of the major things to know is that there are at the moment 2 types of prompting techniques for text generation models. So some of the ones that we discussed here are these what's called in context prompts, where the model is just continues based on the probabilities of the text, but then you have this other family called instruct or command, where you, instead of saying this is a list of X, you can say generate a list of X, where the model is actually tuned to respond to instructions or commands that are given to the model. And both are useful. So a command model or an instruct model is useful, and it's easy for newcomers to get good outputs quickly. But then once you get a little bit more advanced and you need more specific things out of the models, examples help. Even if you use an instruct model and you give it examples that help the model, helps the model guide. Because some things are difficult to describe in an instruction or in a command. So I can't really tell the model, write an article in the style of X or Y. But if I, put in a couple of paragraphs or maybe an article or two by that person, the model is able to extract that sense of style from that author, if that author is not, let's say, well represented enough in the data set. And just on prompts, I think a lot of this, before we leave, a lot of this also carries over to image generation prompts. So there has to be a little bit of investment in the prompt. So even if you're using the same model, so stable diffusion for image generation, the prompts that used to work for version 1.5 no longer work for version 2, because it's a different data set that was trained on. The models are a little different. So even if you're using stable diffusion, there's some effort on prompt exploration and prompt understanding that you need to invest in as a developer to really understand the space of that model and what it's able to do. For image generation, there concepts of the prompt needs to describe what the subject is, so what you want to appear in the image, but you also, the second portion of a prompt is the style. So do you want it to be a photo or a illustration, or it's an anime, or it's a screenshot from a video game, and what style is it in, is another major component. And then one component that is being used more and more now is the negative prompt, where you try to nudge the model away from certain concepts and say, focus on this rather than that. And so that's another consideration. For text generation models, there's this concept called prompt chaining, where you can think about using multiple prompts to achieve your specific result. So let's say you want to write a story about something. You can basically tell the model to write you a story about X and get the story back. And when you're first coming to generative models, this might be the mental model that you have. But then to get longer stories or maybe better flows, prompt chaining is a concept that will serve you better. To give you an example, this is a paper from DeepMind called Dramatron that showcases the system that uses text generation models. So you can use this with Cohere's generation models, or a large GPT, and they do share their own sort of prompts. And it says this model is able to generate a full screenplay. But it's also the process or the flow allows a human author to control that generation, but the model can do it all without any human intervention. But to get the best results, it's good to incorporate, to use somebody in that process. Now, what the process here is that to generate this story, you don't go to generating the prose and the words of the actual story first. No, that comes at the end. You have these intermediary steps where you generate and fill the world of the story first before you generate any word in the final story. And so this method starts with you writing a short description about your story. So 2 or 3 sentences that they call the log line. And then that is used to generate a number of things. So let's say you write a log line or a short description of a story. The next thing would be to generate characters for the story. And so there's a specific prompt for a character generation that says, okay, these are 5 characters. These are their names. This is what they're after. And then are you happy with that or not? So you get to edit it or generate multiple sets of characters until you find the one that you like. And then once you're happy with that, you put that aside. So you've generated your character set. And then you can go to the next level and say, okay, what are the story beats of this story? And they use formulas that are commonly used for stories like the hero's journey, to generate these story beats, also given the characters. So this prompt for generating the plot includes both the log line, which is your story description, but also the characters that were generated in the previous one. And then once you do that, you can also generate the descriptions of the locations. And then once you have all of that world information generated, and none of it specifically, let's say, is part of the final story that you're generating, you can start to generate, okay, scene 1 is this scene, that's what happens, it happens in this location, and this is the dialogue between these characters. And you can refer to this Dramatron paper to see exactly how they do it, and they actually, wrote a play with it and they staged it, and it was performed by actors. So this is one really powerful method that you can think about for adding in your toolbox for more sophisticated or more advanced generations. And while we're on this topic, you can extend this to the next level. So prompt chaining is using multiple prompts for a text generation model. So you give this language model prompt number 1 and then prompt number 2, and then you plug in the output from prompt number 2 into prompt number 3. But in this flow, there's nothing to also stop you from using image generation or other types of models as well. So, you generated characters, why not generate illustrations of these characters? If you've generated descriptions of locations, why not generate images from them? Even if you don't, necessarily use them, finally, they can be an inspiration for an author. And so this is the next sort of layer of thinking in these generation systems, of chaining them together, thinking of them as a pipeline, not just one model that you give an input to and get an output from, but no, these are pipelines or complex systems where you can use them for 5 or 10 or 15 steps, and use an image generation model here and text generation model here, and their output sort of feeds each other. One very important idea that I think is going to be widely used this year is this idea of retrieval generation. And so large language models are good for a lot of things, for generating coherent text, but they're not the best at fact-based question answering. And in the research domain, a lot of the models that show a lot of promise here is when the model is able to access that information, whether it can, for example, search the web, or it has a database of world information that it can access. And this also enables us to use smaller models rather than these sort of massive ones. So this is a trend that is really useful and powerful, and you use the language model for its language capabilities, but then you augment it with the world information that is relevant for the use case that you're tackling. This is just a quick look at how these language models are trained, where they're trained on just, initially they're trained on predicting the next word. So we get a lot of text from the web, and it's called a language model because it does this language modeling task of predicting the next word. So we give it so let's say we get these pages from Wikipedia. We have a sliding window, and we say, okay, these are 5 words from this article. You, the model, need to predict the 6th word. And we withhold that word, and the model would predict a word, and we'll say, no, you predicted the wrong word. This is the actual correct word. This is the difference between your prediction and the actual one. That is called the error or the loss. And so we update the model, so the next time it makes a prediction, it makes less of an error in this step. And then you do this with a vast amount of text, and that's how you end up with a language model. And that tends to be sort of the first step in training these models. And then you have other you can tune it or fine tune it to do better at specific tasks, including following instructions. So that's sort of another following on that theme of using multiple systems. So we'll be talking about neural search or semantic search, but generation models are able to empower other systems by generating synthetic data. And so that's a very useful capability. These are 2 papers on how generative models can help create better search models by, let's say, if you're building a search engine and you have a bunch of documents, you can use a generative model to generate queries for these documents. And then that becomes a part of the training data for your search or retrieval system. And so in your toolbox, language models are also good to generate synthetic and training data. These 2 papers, the one on the left is called GenQ. It's a method called GenQ, generate query, I think. The one on the right is called InParse, and there's a follow-up work that came about it recently as well. And this is what the prompt looks like. So you say document, and then you put the contents of the document here, and you say question, and the model generates the question. We touched a little bit on this, so just not thinking about or just relying on the information stored within the model, but actually thinking about a model as a part of a language processing system that is able to search the web or a database and get the information back, let's say a section or a paragraph containing the information back, plugging that into a prompt and having then the generation model answer that question as informed by or grounded by a source of information that hopefully is reliable. We've open sourced at Cohere. We've open sourced this chatbot that does exactly this, where you ask it questions and it's able to go and search the web. It gets for you, the end user experience is that you ask it a question and it gives you an answer. But the process in doing that is discussed in this blog post, and the code is shared in this repo, and the flow is what you see here. So you have a question. We use a language model to sort of understand the context of this question, and then it goes and searches the web for answers for this question, and then it identifies the most. Let's say it looks at the top 10 results. It looks at the contents of the pages. It gets the paragraphs that are most relevant for the question, and then plugs that into a generative model prompt. And here, the generation model is able to answer that question in a better way. So the final model doesn't only see the question; it sees the question and a lot of context, which was retrieved from the web. So this is a very powerful pattern for these retrieval augmented language models. And I finally end by just some criticism on the naming of generative AI, in that it doesn't really capture everything that is exciting in AI. There are a lot of exciting areas in AI and that are reliably useful, more so than generative AI, and you should be thinking about them in your toolbox as well. So search specifically is this one area where AI is enabling us to do incredible things that were never possible before. One of the best examples here is In 2019, this paper called BERT came out of Google Research, and in about 6 to 9 months of that, it was powering every query in the English language in Google search. And they call it one of the biggest leaps forward in the history of search. So it's good to augment the excitement about generative AI, about other adjacent areas, and a lot of the times that use similar or the same models. Another area there is like understanding. So generation, a lot of the times, can benefit from an understanding system. I'm really excited about this area of multimodal. So you have a language model and you have a vision model, and then you can train a model on both types of modalities, and you end up with a multimodal model. I think that's going to be really exciting, and it felt really magical sort of when I first came across some of these, let's say, image captioning models. So these are models that you give a picture to, like this one on the left, and it says this is a group of people shopping at an outdoor market. There are many vegetables on the fruit stand. Now, I had been this is an example from 2015, and as a software builder, it feels like magic. Like none of the software I was trained or I was building was able to do this. But then AI and machine learning is enabling us with these use cases more and more. And that, while it includes the generation step on the right, the understanding part is one of the most impressive parts of this setup. Now, these types of models have developed a little bit since then. So, what has changed in 7 or 8 years since this image generation model? 10 years ago, there was this blog post by Andrej Karpathy, who was he was a researcher and instructor at Stanford at the time, and then he went on to lead AI at Tesla. And he was saying that this image depresses him for a few reasons. Just when he thinks about the state of computer vision at that time, 10 years ago, that there are some difficult things here that are very difficult for models. And at that time, it was very hard to see the model having much progress on them. So one is, how many people are in this image? And then, because if you're going to count it, are you going to count the reflections of the people in these two mirrors or not? Will models be able to pick up on this subtlety? What is Obama doing here? So you see a person on a scale and you see somebody stepping on that. So there's a little bit of a practical joke here. And is this person aware of it or not? Will a model, an image captioning model, be able to pick this up or not? And it seemed not to be the case 10 years ago. This is DeepMind Flamingo. This is a demo. It was presented with the same picture, and generates a caption, and it says this is a picture of Barack Obama. He's a former president of the United States. And then this is a multimodal model that you can have a conversation with. So you can ask it questions, and it will use both the text context and as well as the image to generate its outputs. And so here the prompter asks the model, how many people are in this picture? And the model says there are at least 5 people, which is a really good answer, saying at least first. And then the people that I see here are 1, 2, 3, 4, 5. There's a 6th head peeking out, but that's not a bad guess. Where was the picture taken? The model says it was taken in a school. How many mirrors are there? There are at least 2 mirrors in the picture. What is the person standing on? The person is standing on a rug. And then the prompter corrects the model, saying he's standing on a scale. The model says, I think you are right. What is he doing? He is looking at the scale. Where is Obama's foot positioned? Obama's foot is positioned on the right side of the scale. What happens as a result? The scale shows a higher weight, the model says. Is the person on the scale aware of it? The model says, I think he is not aware of it. Do you think that is why people are laughing? The model says, I think so. And so this demonstrates, a bunch of these interesting concepts. So one, the idea of multimodal and the models and how exciting they are, and then how they've developed since then. But also, this is a really good point to think. Would the model have picked up on the subtlety of this practical joke if we didn't sort of goad it in the prompt or give it these hints or not? That's one. And then two, how reliable is this behavior, or is it a cherry-picked example or not? But then one thing we learned from this prompting, this is actually a prompting technique. So this is called chain of thought prompting, where you enable a model to solve a hard problem by making smaller advancements and smaller steps at it. So I think this is a great demonstration for many of these ideas that we've discussed. So yeah, just in summary, generative AI is impressive. It's not reliably impressive. It needs various playbooks and the ideas of grounding, and it's not generation is not the half of it. So understanding and search are very exciting, and they can augment these models and make them better. So yeah, it's time to build. These are some links to Cohere and some of the notebooks. So we have code that you can use directly to build neural search. We've just released a multilingual understanding language model that understands over 100 languages. There's also a notebook for generating stories and demonstrating them for Stable Diffusion, kind of like the concept that we've just discussed. We welcome you to join our Discord. I'd love any feedback. And then thank you for having me. Happy to answer any questions if that's...
Thank you, Jay. Yeah, there are a few questions here we could dive into, maybe just a couple, and then we'll wrap things up. What an awesome presentation. Can you see in the chat, or would it be helpful if I called a few of these out?
I would appreciate if you call them out.
Okay, we've got one here. What are examples of understanding systems? This is from Sam.
Yeah, so understanding. I'm using, let's say, quotes around understanding. So there are multiple things that you can do with understanding. So a search system, for example, does some sort of understanding where you give it a query and it says, okay, these are the best 3 results to answer this question, or that are most relevant to this query. Another type of form of understanding is a classification. So when you have a model assign a tag to messages, let's say it's classifying emails by this is related to sales or to marketing, and so it does that understanding or classification, and let's say tags it in a CRM or forwards it to the right person or the right team, or it says, okay, this is related to this specific product of ours. Let me sort of ping the people related to it. So these are different sort of portions or tasks that involve understanding of text.
Great. What are your thoughts on human-in-the-loop approach to overcome some of the generative AI's limitations?
Human-in-the-loop is necessary for a lot of use cases, and the more high stakes the use cases, like the more of a requirement sort of having a human in the loop. And there are ways to, let's say, maximize the value that we can get out of these humans and their attention. So do you give them just a 1 generation and say yes or no, or do you have them choose the best one from 10 or 20? So this leans a little bit on things that we've learned from labeling techniques that enable labelers to be more productive. But human in the loop is definitely one of the most important things that we have currently for until we have really reliable systems for the use cases that we're after.
Okay, we'll do a couple quick additional ones here. What are some of the best ways to learn more about prompt engineering systematically?
So we have a guide on prompt engineering for text models. Every model sort of has its own guide, and that's a little bit of a challenge. So there's a mid-journey style of prompts. There's a Stable Diffusion style of prompts. And then for text models, like some of the methods that are common across them are discussed in our prompt engineering guide, which are the ones that I touched on here. Just having a description for the task, showing examples. If you have a specific format, your examples can show that format that you want, whether it's tags or saying input and output, or so that is sort of the general one, but it tends to be a little bit more specific for various models.
Okay. And if there's any additional information, we'll share it in Slack and make sure everybody has access to it. Last question, then we'll wrap up day 2 here. How should teams think about maintenance of integrated models over time as new versions are released? Is it reasonable to worry about degradation in performance of specific cases, even as standard benchmark results go up?
100%. Yeah, that's a really good question, and a really good and valid concern. And we can learn a lot in machine learning in general from just software engineering practices of shipping test cases that we know the model should succeed at, and test cases that we know the model should fail at. Yeah, augmenting these systems with test suites for the kinds of behaviors that we're after. That worked for us really well with software and catching regressions. If the model breaks a specific behavior that we're used to, either on a unit level, so it's a unit test, or as a integration between multiple components. So I lean heavily on software testing wisdom to actually ensure that the models continue to do what we expect them to do.
Great. Well, Jay, would you be open to additional questions if people were to email you and that type of thing? I know we have more interest here, but I want to be respectful of your time as well.
Yes, absolutely.
Okay, wonderful. Well, Jay, what a great talk. Thank you so much for presenting here at Launchable, and wish you all the best.
Amazing. Thank you so much.
All right. Thanks, everybody. We'll see you tomorrow.